So we've got our ICU cage assembled now, ready for our animal to go in it. Now we need to decide how much oxygen we're going to supply. Now the kit comes with a full set of these things called Venturis. Now what they do is they give you a known concentration of oxygen. Instead of just sticking the tube in and turning the flow meter on and not really knowing how much oxygen you're putting into the cage, these Venturis allow you to deliver a known concentration. So they range from, say, 24%, which is the blue, to 60%, which is the green. What this allows you to do is to match the concentration of oxygen you're supplying to the condition you're treating. Now the cage comes with a full chart explaining this. So here's the chart that comes with the ICU cages. What we're trying to do here with this chart is to match the oxygen concentration you're supplying to the condition that you're treating. So for instance, if we just want to give a rabbit a little bit of additional oxygen pre and post-op, then 24 or 28% oxygen is fine. However, at the other end of the scale, if there's severe compromise of the oxygen exchange mechanism, then we really need to supplement these animals with the 60% oxygen. So examples of this would be chest trauma from hit by cars or congestive cardiac failure. We've decided let's do a rabbit. Let's do a rabbit before we anaesthetize them. We want to give the little rabbit some oxygen. So let's go for the white Venturi, 28%. So that goes on the one end of our tubing. The T-piece comes with a red stopper on one end of the horizontal arms. We'll explain more about what we do with that stopper with big dogs. The other horizontal arm goes into the inlet port on the ICU cage. The Venturi goes onto the vertical arm. Onto the other end of the tubing goes the blank Venturi. This is the one with no holes. Okay? So this acts as a connector to any standard anaesthetic machine. Here. Okay? If you're using piped oxygen, then you won't need the Venturi. That will just go straight on to your flow meter. Okay. So we pop our rabbit in. How much flow rate do we need? Well, the Venturis need a minimum of 2 litres of oxygen flow rate to function. So that is your minimum flow rate. So what happens if we're running 2 litres of oxygen on this 28% Venturi? Well, we know from our flow meter chart. So here's our chart for determining our flow rates with the Venturis. Now the different coloured lines on this chart correspond to the same colour of Venturi. So for instance, the blue line corresponds to the blue 24% Venturi. The white line corresponds to the white 28% Venturi, and so on. Our vertical axis here is the flow rate in litres of oxygen per minute on our anaesthetic machine or on our oxygen flow meter if we've got piped oxygen. The horizontal axis corresponds to the number of litres of air that's drawn in by that particular Venturi at that particular flow rate. So for example, if we take the white 28% Venturi, if we're running at 2 litres of oxygen, so that's 2 on the vertical axis, if we read across till it intersects the white line and then read down to the horizontal axis, we get a figure of 20. So for every 2 litres of oxygen we're running on our flow meter, we're drawing in 20 litres of air. So the total flow rate is 22 litres per minute of 28% oxygen enriched air. Let's do another example that's not quite so easy. If we take the green Venturi and say we're running at 5 litres of oxygen. So if we read across from the 5 on the vertical line till it intersects the green line and then down to the horizontal line, this will come out at the 5 litres of air mark. So our total flow rate will be 5 litres of oxygen and 5 litres of air. So the total flow rate is 10 litres per minute of 60% oxygen enriched air. You'll also notice on the graph beside each coloured line is a ratio. So for instance on the green it's 1:1. This is the number of litres of air that 1 litre of oxygen will draw in. So in the case of the green Venturi, 1 litre of oxygen will draw in 1 litre of air. On the white Venturi, 1 litre of oxygen will draw in 10 litres of air. And this can be quite a quick way of working out what your flow rates are going to be.
Well, we know from our flow meter chart that this 28% Venturi, for every 2 litres of oxygen that passes through here, will suck in 20 litres of air. So 2 litres of oxygen per minute coming through here, 20 litres of air being sucked in, delivering a total of 22 litres of 28% oxygen-rich air per minute into this cage. So that's going to empty this cage approximately every 2.5 minutes. That's going to flush out all the CO2, and more importantly, it's going to flush out all of the heat. That's why we leave the small gap, as I say, about 1 centimetre at the top of the cage. Let's take another example. Let's take, say, a cat which has possibly got some chest injuries, is breathing badly. Well, we're not sure what the injuries are, so we're going to go for the 60% Venturi. That's the green one. The hole's much smaller. So we attach that to the end there, and again the Venturi goes onto the horizontal arm of the T-piece. If we've got it running at 2 litres of oxygen, as the 2 litres of oxygen passes through the Venturi, it will draw in 2 litres of air from the atmosphere. That delivers 4 litres of 60% oxygen enriched air into the cage. Now in this case you might need to turn the flow rate up a little bit. So supposing we go to 4 litres of oxygen, we're then delivering 8 litres of oxygen a minute. 8 litres of 60% oxygen a minute into the cage. The important thing here is that if the animal seems to be getting hot at all, the important thing is to turn the flow rate up. It's the flow rate that flushes out the heat. We've got the gel packs, which we'll talk about later, which will help, but it's basically this high flow rate. Because of the Venturis, we're able to get much higher flow rates than would normally be attainable with just oxygen alone.